In this video, we'll go over the Create Riparian Catchments tool. Riparian catchments are essentially watersheds whose outlets are a length of stream bank. They link the upland drainage area to the stream, giving insights into where surface runoff is originating from and how much runoff a certain riparian zone is having to filter. Each catchment that is delineated will physically touch the stream and be linked to its stream segment through a unique identifier. So first off, let's take a look at the inputs. It requires the stream reach, and this is with or without water bodies. If you include water bodies, riparian catchments will be delineated to shore and bank lines of lakes and wide rivers. Whichever you choose, you must use this same stream reach throughout the remaining riparian assessment tools. So for create riparian attribute polygons, height above channel, riparian function, and denitrifying practices, whichever you used here, use that in these as well. The second input is optional, and that is the water bodies. Input this if you have used your stream reach WB stream feature. Next, we're going to select a riparian segment length. The default is 250. If you lower the length, you're going to have more riparian catchments per stream segment, and vice versa. If you lengthen it or make this number larger, you're going to have less riparian catchments. It also requires the D8 flow direction raster, or D8 flow accumulation raster, the field boundary feature class, and our drainage table. We're going to get one output, and that is our riparian catchments. So let's go ahead and run this tool. It does take a while to do this, so I'm going to let it run while I explain how it works later. I dropped in my stream reach feature class. I don't have any lakes or wide rivers for this watershed, so I'm going to leave this blank. I'm going to leave it at 250 meters for my riparian segment length, and everything else has been automatically populated. My riparian catchments output is going to the correct location. So I'll hit OK, let it go. While that's running, let's go over how this tool works. First, the length of each reach is found. This is carried as the length attribute in the stream reach feature. So in this example, this reach is 1,920.2 meters long. The second step, the number of segments to be placed along the reach is calculated. This is done by dividing the length by the riparian segment length, and then we round up or down. So again, we had a length of 1,920.2 meters. As the default suggests, we will choose 250 meters to be our riparian segment length. So that original length divided by the riparian segment length equals 7.68, and we'll round this up to be about 8 segments. If we take that original length again and actually divide it by 8, we see that we will have 8 equal segments of 240.03 meters. We then do an adjustment for sinuosity. The length of each segment is recalculated based on its proportion of straight line distance to the total. For example, a very sinuous segment will have a smaller proportion of straight line to total length. Let's break this down further. First, we determine the proportion if all were equal, so that would be 100 divided by the number of segments in the reach. In this case, 100 divided by 8, which is 12.5. We then find how much the actual proportions deviate from that assumed equal proportion. So for example, 13.8 minus 12.5 equals a 1.3% deviation. We'll then subtract those differences from the assumed equal proportion and multiply that difference by the total length to get a new length for each riparian segment that has been adjusted for sinuosity. Once the final segments have been defined, we will then delineate watersheds to each segment. Those watersheds are then split by the stream reach, giving a left and a right side to each riparian catchment. The remaining points represent the headwaters, and these are also delineated using the most upstream point of the first order streams. These headwater catchments often have a disproportionately larger contribution to the stream. Each riparian catchment is going to carry a unique ID, and that field is called the riparian ID. The first number in this ID indicates the catchment or reach it is associated with, so you can connect these catchments back to your stream reach. The second number indicates the order, and this will be 1 through however many segments that reach has. And the last number can either be 2 or 1. And 1 indicates that it is a left side riparian catchment, and 2 indicates it is a right side, and that is looking downstream. Any headwater catchments will be identified as listing the catchment or stream reach ID _ followed by the word headwaters. Okay, so the tool is just finished running, and we can go and take a look at our results here. I'm just going to put it under the stream reach. And first I'm going to do some symbolization so you can kind of see how they're broken down. So right now it's just this big cluster of riparian catchments. But if we go into symbology and categories, and let's first just do by riparian ID. Choose a brighter thing, apply. You can see each individual catchment, and you can kind of start to see too these headwater catchments here, and you can just see right away how large they are compared to some other ones. Another way to symbolize them is by catchment, and this is going to symbolize them similarly based on which stream reach segment that they fall along. So I'll hit apply, and now we can see them grouped up nicely. Another way to symbolize them is by subcatchment. This field here is carrying the catchment ID, and then that final attribute, which is which side of the stream segment it's on, the right or the left. So if we hit apply, now by stream reach we can see them broken down with our headwaters still also standing alone. Alright, so now let's take a look at the attribute table here. Just expand this a bit. So this first attribute, the riparian ID, is what I covered earlier, where we have the catchment number first. We have the order number second, and this is going to be 1 all the way through the number of segments along that reach, along with your headwaters. And then the identifier of 1 or 2, indicating which side it is on. And 1 means it's on the left side, and 2 means it's on the right side, and again, that's looking downstream. We then have how many acres this riparian catchment is, the len met, this is the length of stream that catchment falls along, and this is the actual length. Then we have the SL len, which is the straight line length, so the straight line of that stream reach that it falls upon. And then we have the breakdown of which catchment it's associated with, what is the subcatchment it's associated with, and then how many acres within that riparian catchment is to cropland, how many acres is to pasture, and then how many acres are likely to be tile drained. So real quick, I just want to show an example of how you can use some of those attributes to extract more information. So say you were looking to implement some riparian practices or edge of field practices that treat tile drain water, but you would like to know which areas to kind of address first. We can go into symbology under quantities and choose that tiled acres value. I'll keep this color scheme, But you can see this is starting to break it out into classes, how many acres within each catchment are tile drained. And we'll hit apply. Okay. We can see these red to orange colored catchments have the most acres that are tile drained. Not surprisingly, some of them are headwater watersheds. Well, most of them are headwater watersheds. So you would now have a better idea where those edge of field practices or riparian practices that address tile drain water would be better suited as compared to these blue areas where you're likely to have less tile drain land there. Here's a brief recap on how to run the Create Riparian Catchments tool.